This video is going to explore exponential functions. We're going to look at a few examples to identify what kind of exponential function are we looking at and to determine if it's an exponential function based on a table of values that we're given. So first off, what is an exponential function? An exponential function is just a mathematical function in which you do have an exponential expression involved. The main format that you're going to see these exponential functions would be f of x equaling a, which is a constant, or you can think of it as our dilation, times b, our base, raised to the x power, which is our variable. Now, when the base, the b, in this case, when the base is greater than 1, when it's greater than 1, it's going to be an exponential growth. That means it's increasing at a slow rate, and then all of a sudden it rapidly increases uh, later on down the road. For when b is less than 1, but it has to be greater than 0, it's important that the base can never be 0, because if the base is 0, if you raise 0 to any power, it's going to be 0. It's not going to change anything. Therefore, it would not be an exponential function. So the base has to be bigger than 0, but if the base is less than 1, but greater than 0, it'd be an exponential decay. That means it's declining or decreasing at a rapid pace, and then eventually it gets close to being leveling out. So in our two examples here, we have two graphs here. We're going to identify if these are exponential growth or exponential decay functions. Now in example 1, if we're looking at the function, just the graph alone, not the equation, but the function alone, it's starting up from left to right. It's going down at a rapid pace, and then it levels out to the right. It goes downward. So that is a clear sign that this would be an exponential decay. Now, if you were wondering how can you determine if it's a decay if you don't see the graph? Well, if you look at the function here, our b is right here, 1/6. Because our base is a fraction less than 1 and greater than 0, that means it's going to be a decay. In example 2, from left to right, it stays a little bit lower, then it increases, and then it all of a sudden rapidly increases after it hits about 1. Actually, a little bit past the 0. When x is a little past the 0, it jumps up greatly. So this would be an exponential growth. And if we were looking at the equation, our b here, you can see our b is a 4, which is greater than 1. And anytime the base is greater than 1, or you can think of that as our common ratio is bigger than 1, it's going to be a growth model. The next part is determining, is this an exponential function based on a table of values that we're given. Now, when we're given a table of values, there are a couple of things you have to keep in mind. The values, the x values, must have the same interval. So going from one x variable to the next x variable to the next one, they should all be increasing at the same value. So in example 3, I go from -3 to -2 to -1 to 0. These are all increasing by 1. And over here, going from 0 to 4 to 8 to 12, they're all increasing by 4. So that's what you want to look for when you're looking at a table of values. The y values, they must have the same common ratio. So how do you find the common ratio? To find a common ratio, you take one y value. So if I have y value 2, I'm going to be subtracting it from y value, or not subtracting, you're going to be dividing by. So let me So it's going to be y2 divided by y1, and that's going to give you your ratio. So you always take the y value divided by the previous y value. So here in example 3, if I take 16 and divide it by the previous one, it's 32, this will give us 1 over 2. And then if I have 8 over the previous one of 16, that gives you 1 over 2. And then if I get 4 divided by the previous y value of 8, that gives me 1 over 2. So that means it starts off larger and then it goes down to a smaller number fairly rapidly. But the common ratio you can see is always the same, and our x coordinates are all increasing at the same amount. So yes, this is a exponential function. We would consider this, since the common ratio is 1/2, my y values are decreasing, we would say this is an exponential decay. Now example 4, we can see that our x's are increasing by 4 every time, and our y values, we want to see if there's a common ratio. So I take 9 divided by the previous y value of 6, that gives us 3/2. If I take 12 divided by the previous one, which is 9, reduce that, that would give us by 3/3, that gives us 4/3. And then if I did 15 divided by 12, reduce that one by 3/3, that would give us 5/4. You'll notice that our common ratios are not the same. So no, this is not exponential. What this is would be linear, because these are all increasing, the y's are increasing by 3's. And you can see my ratio, or my slope would be rise over 1, or change in my y divided by change in my x. That would be 3 over 4. So this would be a slope, a linear line with a slope of 3/4. So those are some examples of how you can identify exponential functions, and from not only from a graph, but from a table of values.